Hello, this is numbers lesson 4.5. In this I will discuss question based on theorems while calculating the remainder. Now as these questions are based on theorems, these questions are not much very important from exam point of view. They are not very important, you can say not important from exam point of view, but still you must know sometime if a question comes, then you should be able to solve the question. First concept says that a raised to the power p minus 1k divided by p. The remainder will always be 1, where p is the prime number, and a and p are co-prime. Co-prime numbers are those whose SCF is 1. It means that there is no common between a and p. For example, if I want to say that the p is 11, the prime number is 11, then any number, let's say 8 power 11 minus 1k will give you remainder as 1. For example, now what I am saying, this 8 power 11 minus 1, 8 power 10k by 11, remainder will always be equals to 1. For it means that 8 power 10 by 11, the remainder will still be 1, or 8 power 100 by 11, still be the remainder would be 1. You can put any value of k. K could be 1, 2, 3, 4, 5 up to infinity. K can be any positive integer. So that's the theorem. A and p must be co-prime. There should not be any common number between a and p. That's the meaning of co-prime. And then the remainder will always be equals to 1. Let's discuss a question based on this. Now, for example, the first question is 31 raised to the power 157 by 79. What will be the remainder? Now here we can't solve the question by the basic concept that replace number with remainder, because 79 power, it's very difficult to calculate. So what we will apply, we will question 1 is 31 power 157 by 79. You need to find the remainder. Now we can't solve this question by simply applying the basic concept that replace number with remainder, because it's very difficult to find the some power of 79 which gives the remainder plus 1 or minus 1 with 31 power something. Now what we will do, we will apply some basic concept, some theorem that we discussed in the previous slide. You can see that 79 is a prime number. So 79 is a prime number. So 31 power 79 minus 1 into k. Can I say 31 power 78k by 79, the remainder would be 1. This is based on the theorem that I just discussed. So 31 power 78k by 79, the remainder would be 1. Now for put k is equals to 2. So can I say that 31 power 78 into 2, 156 by 79, the remainder is 1. So what we will do, we will break this 31 power 156 into 31 power 1 divided by 79. Now apply our basic concept, replace number with remainder. Now 31 power 156 by 79, here the remainder is 1. 31 by 79, remainder is 31 divided by 79. So final remainder is 31, and that will be your final answer. Question number 2 is 7 power 91 by 11. You should first try to solve this question yourself, then look at the way I have solved. Again, we will apply that concept whenever the denominator is a prime number. So 11 is a prime number. So 7 power 11 minus 1k, the remainder will always be 1. Can I say that 7 power 10k by 11, the remainder will always be 1. Here the 7 power is 91, which is not a multiple of 10, but nearest multiple of 10 would be 90. So if you put k is equals to 9, so 7 power 90 by 11, the remainder would be 1. I am putting k is equals to 9. You can put any value of k, the answer will still be same. So it means that 7 power 90 by 11, the remainder is 1. So what we'll do, we'll break this 7 power 90 into 7 power 1 by 11. Now 7 power 90 by 11, the remainder is 1. We are now applying our basic concept, replace number with remainder. 7 power 90 by 11, we know that remainder is 1. So 7 by 11, remainder is 7. So 1 into 7 is 7 by 11, remainder is finally 7, and that will be your final answer. Next concept is this concept is not as complicated as the previous one. That was difficult to remember. This is not difficult to remember. P minus 1 factorial by P. The remainder is always equals to P minus 1, where P is the prime number. I hope you understand the meaning of factorial. Factorial 5 means 5 into 4 into 3 into 2 into 1. You can write factorial 5 as 5 into 4 into 3 into 2 into 1. You can write as 3 factorial. So you can check this. What is the first prime number? 2. If P is 2 to 2 minus 1, 1 factorial by 2. You can see that remainder is 1. 1 factorial is 1. So 1 by 2 remainder is 1. Next prime number is P is 3. If you put P is equals to 3, then 3 minus 1, 2 factorial by 3, you can check that remainder is equals to 2. Next we can see that next prime number is 5. So 4 factorial by 5. If P is 5, P minus 1 would be 4. 4 factorial by 5. You can see that 4 factorial would be how much? 4 into 3 into 2 into 1. That is 24. You should divide 24 by 5. 24 by 5, the remainder is 4. So it means that 4 factorial is there, so remainder is 4. Same way, if the any prime number you take, let's say you take 7, so 6 factorial by 7, if you calculate, the remainder would be 6. Same way for bigger number, that is very advantage. For example, 97 is also a prime number. So 96 factorial by 97, the remainder would be 97. Straight away you can answer based on the same pattern. It means that P minus 1 factorial by P, remainder will always be P minus 1, where P is a prime number. Be careful. Now first question we can simply take that 36 factorial by 37. What will be the remainder? Now we know that 37 is a prime number and that is P minus 1. This is of the form P minus 1 factorial by P. We know that remainder would be P minus 1. So in this case, the remainder would be 36. That is numerator. So 36 will be the remainder. Second question I am going to discuss, that is a bit difficult than the first one. What is 9 factorial by 11? What will be the remainder? This is a bit tricky one. How to solve 9 factorial by 11? We know that 11 is a prime number. So 11 minus 1 factorial. 11 minus 1 factorial by 11. The remainder would be 11 minus 1. That is 10 factorial by 11. Remainder we know that that would be 10. But we don't know about the 9 factorial. Now how to solve this? We will use this 10 factorial concept. We know that 10 factorial by 11, overall the remainder would be 10. Now we can break this 10 factorial as 10 into 9 factorial by 11. Overall remainder should be how much? 10. Now you can see that we will assume that 9 factorial by 11, the remainder is R. So what we'll do, we will replace number with remainder. So 10 by 11, the remainder is 10. Now what should be 9 factorial by 11? So that final remainder is 10. Now while calculating the remainder, we keep sign as it is. So let's say remainder is R. So 10 into R by 11, final remainder is 10. This is R here. 10 into R by 11, the final remainder is 10. Now how to calculate? Now what should be the value of small r? So that product should be 10. Can I say that r would be 1 only? 10 into 1 by 11, remainder would be 10. So small r would be 1. What was small r? Small r, the remainder we assume that 9 factorial by 11. So it will be 1. So final answer would be 1. Now last question of this lesson, 8 factorial by 11. Now please try to solve yourself, then look at the way I have solved. Let's say assume that remainder is small r. Now what we know that 10 factorial by 11, the remainder would be 10. This is what we know based on the concept I just discussed. So what I will open this 10 factorial. Can I say this 10 into 9 into 8 factorial by 11. Can I say this is 90 into 8 factorial by 11. Overall remainder should be 10. Because 10 factorial, this is only 10 factorial we are expanding. Overall remainder we know that 10 factorial by 11 is 10. Now what we do, we will calculate the remainder on the left side. 90 by 11, 11 8s are 88, remainder is 2. Again by the same concept, replace number with remainder. 90 by 11, remainder is 2. 8 factorial by 11, let's say remainder is r as we have assumed. 2 by r, 2 into r by 11, final remainder should be 10. What should be the value of r so that remainder remains 10? Can I say that r should be 5? Because 2 into 5, 10 by 11, the remainder would be 10. So r can only be 5. Smallest value or minimum value of r is 5. So finally the remainder is 5. We have to take the minimum value in such case. So that was all about numbers lesson 4.5 question based on theorem. Thank you.